a very good afternoon to all of you. Welcome today to my session where I show a path-breaking change that we are doing here at Snowflake. Today in the morning, we talked about what AI is. We talked about code and data. And today we are going to see where Snowflake is making the change. I'll tell you what is the single most important point that I want you to take away when you walk away from this room, and let's wait for the moment. With that, I will first get started with Snowflake, a optimized, managed, consumption-based SaaS application or a platform which is cloud agnostic in nature, available on AWS, Azure, and GCP. If I have to define Snowflake in one single sentence, this is how I would introduce it. And now, on Snowflake platform, we are working on path-breaking technologies, where you can bring in your LLM models, you can bring in LVM models, and today, my topic encompasses the same. With that, taking out the introduction out of the weeds, I'm Sarita, and thank you so much for the kind introduction by AIM team. And I work as Senior Solutions Engineer, and happy to connect with customers and all of you in the audience. If you want to talk to me, you can come down to our booth here, which is right out of this room. Today, the topic is image modeling, the next path of technology which we are taking. So today, since morning, I have been observing this room. I have been an audience in many of the instances. Just imagine, one day, the slide goes blank. What would be the single most important or the inflection point that you have in the entire human history for us to work on our laptops? Anyone? Single most important inflection point in human history. What would have been that particular discovery which led us to mobile phones, to laptops, and today in a lighted room? What was that? What would that be? Any? Sorry? Chips? Sorry? Internet? Okay. Someone said electricity? Who was that? Oh, awesome. Thank you so much. I was looking for the word electricity. And if I tell you that was the single most inflection point in the past 100 years that we have had till now to go from this particular screen to the next one, that would have been electricity. And artificial intelligence is the next electricity. And I have a news for you guys. Today, we are standing at an inflection point where AI is going to change how we work. Yeah? So with that, and how we are going to transform the entire human history for the next 100 years is in our own hands. And that is where the change makers are sitting with me in this room and sharing their ears with me. With that, let us take away what it has been, how the journey has been. I saw a lot of cool questions being asked here. We know about supervised learning. The last decade that we saw was more about supervised learning. I do not need to introduce you about supervised learning. You give an input and you get an output, and that is where supervised learning comes into picture. There are lots and lots of algorithms around the same. There's a lot of code which goes into the same. Then came unsupervised learning, where we were trying to build up models where we could get in unexpected data sets. From them, we could derive some value. But this current decade has been around generative AI. What do we do? And in very, very simple terms, I know none of you needs an introduction into Gen AI after the ChatGPT boom that we had about roughly a year back. But then, what does it do? And how does it do it? We have got a prompt, I love eating. And then we go from there, we pick up words. And how do we pick up words? We pick them up from the models which we have trained on the internet. So just now, Abhinand, who has worked on Tamil Nama, was telling us about the challenges that we have, right? We do not have enough information on our local languages to actually build these kinds of models so that we can tokenize them, embed them, vectorize them, and use them. That is something which we are trying to actually solve for. But added to that, if and how we are working together today on top of Gen AI is because all of this data is actually present from internet, whatever captchas you have filled in, whatever words you have filled in, whatever Wikipedias you have learned, heard, contributed to. In fact, Quora, Facebook, all those things that you have contributed to with your own English knowledge, all of that has contributed to this particular model training and building. How does it happen? There are multiple answers which are possible as a part of the generation process, and my AI gives me that output. How it works with the help of supervised learning, it could have anything. My favorite food is a bagel with cream. And I could actually take that as an input and get an output which would be something which predicts the next word, because it is taking an input of thousands and thousands of parameters. It is reading thousands of books to understand that the context means this. And there have been multiple papers, and some of them as backdated as 1940s, and some of the papers which are very, very popular, like Attention is All You Need. So some path-breaking ones, some around transformers, around GANs, around deep learning. I will not go deep into them. But what they have led us is to this point, where I take up this data, and I can choose and select what would be my next word, or this is where my LLMs are right now. This could actually pertain to multiple tokens. This example is for English. You could have it for multiple other languages, some of them being French, Malayalam, Tamil, which we just now saw, and many others. So these are the things, or this is the use case that we have solved till now. So what is it that we would see in the future? So this is what ChatGPT has solved for us till now. This is what our LLMs have solved for us till now, and some more. I met with a person who has worked on data which belongs to music industry. I was talking to a person who has worked on risk management and data related to climate changes and how do we make the climate. So there are different kinds of use cases, but mostly around text. So where are we going next, right? And why text? So if I would just chart it out, all the AI projects that we have done till now, it would be more towards, that graph which you see, which is shooting over the top. It is more around ads and web search, which are much more straightforward, and they need only the text data. And there are specific tools around the same which help us in getting that data through. But then we also have another set of data for which we need better tools. What is that? For example, there is a pizzeria. There are a lot of pizzeria. I'm a big fan of Domino's pizzas. For example, there is a pizzeria. My friend has one, and they would like to understand how much cheese has been spread, what is the consistency, how do I ensure there is customer satisfaction every time I deliver a certain piece, right? This is a use case, but how will you solve it? You need the pictures of the pizza that my friend's pizza place makes, right? Next, I have had a customer who wanted to know whether his current agricultural crop, they deal with coffee, they deal with trees, they deal with wheat, and what they wanted to know was what is the current height of the wheat crop so that they could cut it and get the highest or maximum harvest out of the plants. Just imagine if we could get the maximum output from all the wheat fields, and we are a country of 1 billion, and we are one of the largest exporters. We were the largest exporters of wheat after Ukraine. After the Ukraine-Russia war, equations are changing slowly. But then this wheat production was something which we used to feed. We are the rice bowl of the world. There is a lot of paddy. Just think about it. Just taking it to paddy, to peas, to a lot of other pulses, right? And similarly, there is other use case of material grading. For example, you want to know about what is the grading of the materials to use for construction purposes, for other element classification, for coal mines, for metallurgical uses. Similarly, there is a very important use case which I am going to handle today, which is medical images. So do you see a common pattern here? The common pattern here, if you can term it, please shout out. Otherwise, I'll just point it out. The common pattern here is image. The common pattern here is you need specific, specialized data to process this kind of long tail use cases. And do you have that? What would you like to change to bring in your companies, your customers, your profiles into looking at all this data? You would need tools which would be able to process the specific images that you have, because they are customized single-time processes or single-time pictures or images, one. And yes, these images may be available on the internet in a very small quantity, but usually, what do we upload on internet? On Instagram, on Facebook, smiling faces, pet pictures, family pictures, birthday photographs. Those are not the images which we use. So we do not have a repository which we can actually tap in to teach our models that this is how you will work. Whereas in text, it was absolutely different, because we were talking in a specific language. In images, we do not have that. It doesn't hold right. That is where what makes it really important is that we will walk the path of a new kind of prompting, which is visual prompting. And it is also important that we have all of these customized images and customized data in my own database or my own data solution, from where I can pull that out and I can process the same. The second is we have to think in the manner of data-centric AI, rather than from model building to data-centric, right? So we will move away, or we have the maths with us, we have the statistics, we have the cross-loss, everything of that sort. We have the models, but then now we have to think a little different. That is, AI was always code plus data, and we have always put a lot of emphasis till now on top of code, and we have been working on top of it. What should change? And what would change in the future is that the same concept will apply. We will walk a path of human understanding data, or a path where just now we saw some examples from different models where, let us say Gemini, or different models in which we were talking about very fast, but all of the use cases that we are solving are human-based. So if we have to make an application which is human-based, we need to go from code to data. We'll have to make this change and walk that path, and that is where the data-centric AI comes into picture. So computer vision is the next wave of revolution, which you saw with Gen AI, that this would be something which would follow and which will take us to the next steps, is what we feel. And where do we stand? We stand at Snowflake to give you that data which you own. And that is the most important thing. And once your data comes into Snowflake, what you would be able to do is have all of the data governed, secure, and still apply your machine learning models on top of it. Your Jupyter notebooks will run on it, Hex notebooks will run on it. It is a true polyglot. You can work on Python, Java, SQL, and everything. And there is an entire demo around the same. If possible, I'll run you through. So why is the problem so big. Why did I choose? There were so many use cases, but I chose the medical images. Here are two images right now in front of you. Can anyone tell me which of this has got pneumonia, which doesn't? Yeah, left one is pneumonia. Oh, wow. Cool. So, yes, that's absolutely right. She's absolutely right. And I actually keenly observed and I placed these photographs so that you can tell me. But now think of those radiologists who do this day in and day out. There are 4.5 million pneumonia cases worldwide, of which 2 million do not see the next day, of which 1/3 are children below the age of 5 years. If AI or computer vision can make a difference, and even we see a change of 1 or 2% of this population, and especially for India, where doctors are a rare commodity, are like next to God for all of us, with our population, just imagine the impact that we would have. And that is why we chose this particular use case for all of you. So this is where I would just marry the use case with the data set. What I would do is, there is a demo which I would like to run. I'm not sure how deep you would like to go into the technological pieces of it, but I'll just run you through what Snowflake can do. The lowest, the below part is where I would like to start you from down to up. Snowflake has got all the images. So Snowflake is a database. You can get all your images into its staging. After you have done that, you take those images. What you would need is, to train these large models, you need GPUs. So we have got something which is called as Snowpark container services. I'll tell you what they are in next few slides, if possible. And after you have done, you have identified what are the GPUs, we go ahead and we do a kind of transfer learning, all on top of your data, on top of Snowflake. You no need to take out your data, no need to, so this is all non-sample data. This is non-Kaggle data. For now, I'm going to use it from Kaggle. But non-Kaggle data, this is your own data where you are using it live. And then what you do is, you will do a model registry where you can actually keep your versions of your models, and then you can use as per requirement. You can optimize your hyperparameters, you can use them, and then you can fit that model on top of your data right in Snowflake. Yeah? You're building the model, fitting the model out there along where data is. And then what you get, we have also acquired the company which is Streamlit, which you have been hearing since morning about. Streamlit apps, Python code, Python framework. So they don't need introduction in themselves. So Streamlit is something which works with Snowflake. We have an open version. We also have something which is Streamlit in Snowflake. So the most exciting part is, me being a developer first, is that within 15 lines of code, we can make an application and we can show what it would look like. So how it would look like would be something of this sort. So I would, I am supposed to, there is no internet. So my application would look where I would have the pneumonia and the non-pneumonia pictures, and I have a diagram or a screenshot of the same, most probably, just in case. So this is how the Streamlit app would look like if in case it would have been up. This is what you would have seen. There would be a URL which we would go through, and then you would have all the pneumonia pictures, pictures of these X-rays, and then you would see that what was the original diagnosis and what is the diagnosis that the model makes. So there are some places where we actually identify pneumonia as pneumonia or normal as normal, and what we also do is we also vary. Okay, so our models are not 100% perfect, but we do not want to go there. You can always optimize, always make the things better, but then we just wanted to show you a glimpse that this is what is possible on top of the data set. You can choose if the system would have worked. I'd have shown you that if you choose the normal image count and the pneumonia image count, you can actually change the parameter. You can choose as many photographs that you want to take, and then just click on that run inference, and you would be able to run the inference. How do we reach here is with the help of an architecture diagram, which I have for you today, which looks something of this sort. So what do we do? What we do is take the images, do the image registry, build a specification or a YAML file on top of it, and then these interfaces actually send out that particular model to train. So that blue box that you see in the between is the one where you're training the data. You log, you have the stage where you have all the information. You have the Torch data, Torch image data loader, because we are using Pytorch. That is where we are using the image data loader. We use transfer learning. We have used ResNet and VGGNet, both VGG16, ResNet 18. For here, I have used ResNet 18 in my code base. I can share the GitHub library with you if just in case you wanted. There is a Pytorch training that happens on top of it, all on your data. And then what we do is we use the model.model registry folder of or API of Snowflake, framework of Snowflake. And then we do the model registry and then deploy the model.model registry.deploy, and you take that model. You can also choose what is the version of the model, and you can deploy the same. After I have deployed the model on top of my own data, what I do is I see what are the values or what are the predictions that are possible. In the morning, in the keynote, when I was talking about machine learning powered functions, I was telling you how Snowflake makes it easy to run AI in minutes. Now I am showing you how Snowflake is actually bringing in all the power of open source LLMs, of your own LLMs which you are building, or in fact here we are talking about computer vision models on top of your own data, and thus making a change, because everything is within the security and governance of your data. Right? So here is the time for the demo. Actually, I've got a entire set of data set which I have, which I have captured with, I hope this is visible. I actually have done this in data science. This is a Jupyter notebook, but I am showing it today in Visual Code, and I'll do it really quickly because I just have 5 more minutes. So you would bring in all your data. So this is real code, guys, okay? So we'll bring in all our data, pip install, bring in the ML Python. So these are the Snowflake Python libraries that we have built with the Anaconda channel. Once you have got that, what we would also do is we will just bring in all our libraries into the system where we are importing for doing these. I'll just take half a minute. See a lot of people coming in. Yeah. Yeah, it's there. Yeah. Hi, good afternoon, everyone who joined us just now. Yeah. Yes, sir. This is the same image classification problem, sir. The classification is not different. The difference is that you are doing it on your data. Yeah.
Architecture that we showed, what part of it is GA? I mean, for available for us to use.
Very good. Let me deal with that question first. Yeah. At the risk of letting everyone settle down.
Yeah.
Yeah. So this is the slide which I had skipped just to save some time. So this is the architecture as per Snowflake. Okay. So you still have the data here. What do you use is Cortex. So Cortex is currently in private preview. We have got Snowpark container services, which is currently in again in preview. But we have got the Snowflake ML APIs, which are in GA, and Snowflake model registry, which is currently in public preview. So we have the setup already through, and we can enable our customers or who have already signed our NDAs with us on Snowpark Container Services also. So basically, you have the entire architecture set which you need to run these particular inference generating models as of today. If you're a customer, we will enable PUPR, and all of the setup is already fine. And this is a working demo that I have right in front of you. So all of this is available on top of Snowflake. Yeah, okay. So what I would do is go back into the code again. We were just starting looking at the code. All the installs, and these are the two things which are important. Whenever you are using Snowpark, you would have to use snowflake.snowpark. Snowpark is the framework which we use for modeling our data. And then you would bring in the data and you would put it on its stage. You would divide it as validation and validation training purposes and also testing data. So all of that is getting done here. I'll skip those blocks. I'm sorry, we are running really late. Next is those files which we have had, we will just divide them into two different portions. One is normal and one is pneumonia. Once we have done that, what we would do is go back and see how our distribution of our data is. So we can plot and we can show the legend on top of Snowflake also with the help of the Jupyter notebooks. After that, what we would do is we would go to the Torch version, and we are taking up that specific model and pre-training the same. There are different parameters which are associated with it, and you would see those parameters and you can choose if they are the ones which you wanted to run or not. After the same, you have brought in the data, labeled the same, divided it, pre-trained the model and got the model ready. You have done all kinds of transformation on top of your data which is available for you. And then your Torch also gets the learning rate loss. So here we use cross entropy loss function. You define all of that. You train your data. Once your training has been complete, so this is where we are doing for as many epochs as we want. We have taken the device as CUDA. So this is where you use the Snowpark Container Services. You could also as well do it on top of CPUs, which are already available on top of Snowflake. Okay. So this is where you train. You have the loss function defined. You have the optimizer defined and scheduler too. Once all of this is done and the data has been trained and the model has come up, what we do is we go in to check how our particular model works and what is the validation or what is the training loss or the validation loss that we are currently having. We see that both of them have a similar kind of a graph, and we see that our model training is actually proper. With that, what we do is we go in and validate the accuracy of the model. We see the accuracy that it is somewhat in parallel for validation and the training accuracies. So all of that is derived on top of your own data. After that, what we do is get the confusion matrix just to understand how our Streamlit application would show the data. How many normals would be predicted as pneumonia and otherwise, right? So we see that normals are usually the ones where we are getting confused. Our model is getting confused. Whereas wherever it is a pneumonia case, it is very good at predicting the same. We don't want someone to go out without a medicine. So this is where we see the accuracy of the model. And then comes the deployment. So everything happens right with your data. I take that particular model, build a model. So this is where I connect with my Snowflake database and build this entire model with model registry. This is where the model deployment with the deployment name of the model happens, whatever you trained just now on top of the data that you have. And once you have done that, what you also do is you get the predictions and you register the same as sprox and then manage that entire model. I will not go deep into that, but the model is also called for inference. So you can train the model, and then whatever time you have spent on top of it, you can use the model again and again to inference on top of the data that you have on your database, which is a huge plus factor. You are not getting it out from outside. You are not sending your data out. You are not using any unsafe APIs, and you are being responsible with your data. So all of this thing happens on top of Snowflake. So that is where we are seeing the change. That is where the AI plus code is something which is really important. So this would be the application that we have, and Streamlit is the one application where I was just trying to refresh my screen, it did not. But that is where on the left you would get the inferences. So inference is something which many of your users can work on, whereas the data and model was built on one area. So getting the images, processing the same, getting the output, all of it is possible on top of this particular screen. So if you have to take only one thing out of this room today, then I want you to take that AI has got code and data as its power play, because we have to make it easy for humans to work with it. And there is a long tail problem statement which we can solve together with the help of data which we have and we own. And Snowflake does it really, really well. With that, I would like to conclude.